Welcome to this explainer on the Great Data Collapse. Look, if you've been anywhere near the data space recently, you already know there is a massive conversation happening right now about the future of our tech stacks and, honestly, the future of our careers. We're actively moving away from this heavy, clunky infrastructure into something incredibly streamlined, and it's got a lot of people scratching their heads wondering, okay, what comes next?
To really set the stage for us, check out this wild quote that's been making the rounds. A user recently made this bold and honestly largely prophetic prediction about the DuckDB ecosystem. They're basically saying that data science and data engineering are going to collapse into a single domain and that AI engineering is just going to become a subset of it. I mean, that is a heavy claim. It suggests this tech is going to completely upend the entire data domain in the very near future.
And this naturally leads us to the ultimate elephant in the room question that we're going to unpack today. Are specialized data domains actually dying? Is the data engineering era, as we've known it for the past 10 years, officially over? Are we all just destined to become generalists again? For some folks, that's a terrifying thought, but for others, it's incredibly exciting. So let's look at the facts.
Well, to answer that, we first have to take a hard look at the pain points of our past. We have literally spent a decade over-engineering solutions for data scales that, frankly, most companies simply do not have. We essentially convinced ourselves that everyone had big data and absolutely needed these sprawling, complex, distributed systems. We were managing super heavy Spark clusters and tangled pipelines just to move and transform standard data sets, dealing with incredible friction and skyrocketing cloud costs. Basically, we were building Ferraris just to drive down the street to the grocery store. Enter the Duck Stack. This ecosystem is tearing down those traditional boundaries by bringing lightning-fast, local execution right back to our workflows, instead of forcing everyone onto a heavy distributed cluster. By combining vectorized columnar processing with in-process analytics, it brings the compute right to where you are. You can execute locally right on your machine, but then, and this is the cool part, seamlessly pair that with hybrid cloud compute when you actually need it. It's giving developers the exact right amount of power exactly when they need it.
Now here's the stat that really blows this whole thing wide open. Over 90%. It is a surprising reality that over 90% of analytical workloads fit perfectly on a single node or a hybrid setup. Think about that for a second. Over 90%. This is what we call the medium data reality. For the vast majority of use cases, managing a complex Spark cluster for standard analytics is rapidly becoming a relic of the past. The data just isn't big enough to justify the headache.
So, if the tool's emerging, and we no longer need those complex Spark clusters for everything, does that mean your data engineer is out of a job? If a single developer can handle ingestion, transformation, and analysis without ever touching complex infrastructure, using tools like DuckDB, Polars, and dbt, it really begs the question, where exactly do the human tool boundaries end and the operational realities begin? Let's look at who benefits first. Historically, data scientists were totally reliant on engineers to extract clean data for them. But DuckDB eliminates that friction entirely, allowing for rapid local queries on incredibly large files. A data scientist can now pull up multi-gigabyte Parquet, CSV, or Iceberg files locally and get responses back in milliseconds. And they're doing it using standard SQL or Python, entirely bypassing the old legacy warehouse bottleneck. No more waiting days for a data engineer to build a pipeline just so they can start their analysis. But hold on, because here is the crucial nuance. While a single developer can handle transformations with these new tools, keeping complex production systems resilient at scale, that still absolutely requires dedicated engineering discipline. Data engineering isn't just about writing fast SQL, right? It's about the operational reality. We're talking strict data governance, dynamic schema evolution, pipeline orchestration, hitting your SLAs. Yes, the tools are converging for sure, but those deep responsibilities for system reliability at scale, those remain very, very distinct. Okay, let's shift gears and move to the AI frontier, because MotherDuck is rapidly becoming the foundational compute engine for modern artificial intelligence. This shift isn't just affecting traditional analytics, it is completely rewriting the playbook for how we build AI applications. Think about AI agents. They desperately need rapid access to structured data. MotherDuck actually allows large language models to query analytical data directly without blowing up your latency or your cloud costs. Using tools like the Model Context Protocol, or MCP, agents can access a low-latency, flexible execution engine. Whether that agent is running via WebAssembly in a browser, in a local Python runtime, or up in the cloud, MotherDuck sits right at the heart of it, providing that vital context retrieval completely seamlessly.
However, while MotherDuck serves as the perfect engine, the broader AI engineering stack remains vast, and it requires its own specialized operational management. So is MotherDuck going to swallow AI engineering whole? Not quite. AI engineering as a discipline spans way more than just data retrieval. You still need specialists for prompt and agent orchestration, dynamic evaluations, model fine-tuning, latency optimization, and of course, crucial safety guardrailing. MotherDuck is a powerhouse engine, but the car around it is still highly complex.
So, that brings us to a really crucial point. If data engineering and AI engineering roles aren't completely vanishing, what exactly is collapsing? Because something is definitely shrinking here, and we need to pinpoint exactly what that is so we can optimize for it.
I'll tell you what's collapsing. It's the feedback loop, and it's being driven by this amazing concept called dual execution. This allows you to test instantly on local memory and then push the exact same code to production. It's revolutionary. You don't have to rewrite your logic for different environments anymore. You execute locally when it makes sense, and you seamlessly offload to the cloud when you need more horsepower, all without changing a single line of your SQL.
And mechanically, how is this supported? With this minimal infrastructure they call ducklings. These ensure isolated, per-user compute that keeps overhead incredibly low. So instead of sharing a gigantic, expensive, constantly running warehouse with hundreds of other developers, where one person's bad query can literally take down the whole system and spike your bill, you get your own isolated instance. It completely prevents those runaway cloud costs and strips away the infrastructure complexity.
When you look at the paradigms side by side, it's night and day. That heavy separation between local development and cloud production is being entirely replaced by minimal infrastructure and instant testing. In the old paradigm, you'd write your code, deploy it to staging, spin up a giant cluster, and just sit there waiting for the cloud warehouse. High overhead, agonizingly slow feedback. The new paradigm? You query local Parquet or CSV files directly in memory, test your logic instantly, and then push that exact same SQL straight to MotherDuck. It literally collapses the time from idea to execution down to almost zero.
So what is the final verdict here? Ultimately, we're seeing data scientists become way more self-sufficient, and engineers are building faster with a fraction of the overhead. The landscape is absolutely being redefined, but it's not being destroyed. The silos are coming down, but the deep expertise required to build resilient, governed systems at scale, that is as important as it has ever been.
Rather than a total collapse into a single, confusing job title, we are actually witnessing the powerful emergence of something new, the full-stack data developer. This is someone who leverages these incredible new tools to manage the entire lifecycle, from raw data ingestion through transformation, all the way up to model deployment without having to act as a system administrator for 100 different fragile cloud services.
Which leaves us with one final critical question for your own infrastructure. Are you migrating your pipelines to the Duck Stack, or are you just watching this massive paradigm shift from the sidelines? The tools to build faster, cheaper, and smarter are literally here today. It's time to decide how you're going to use them. Thanks so much for joining me for this explainer, and I'll catch you next time.